Hello, Cardstack community. My name is Chris C. I'm the founding director of the Cardstack project, coming to you from the land of the Web3. Today, I'm joined by the co-founder of XY SDK, Arie Trouw, who's going to talk about location, about understanding the data aspects of bringing location data and bringing the data trustworthiness to the Web3 world. Welcome, Arie.
Well, thank you, Chris.
So can you tell us a little bit about the work that you have that led you into building this Oracle network, reality Oracle, and how your world in the real world, dealing with actual real items, inspire you to connect blockchain with the reality we live in, not the metaverse, the actual universe. Can you tell us about your journey into this particular world?
Oh, definitely. So I've been fascinated with the imperfection of reality for many years. And actually, I left my previous company in 2012 and started XY. Actually, it was originally called Webble, but started this company with the goal of being able to understand and quantify data almost from a dataistic standpoint of how the world actually is comprised. And so one of the problems we ran into earlier on in that endeavor was, how do we actually share data from node to node in a system like that if the trustworthiness of the data is actually something which is at question, or more important, like this, the origin of where that data came from is in question. So as we were working on that, we did some side projects or side products like our XY Finders, for example, which did quite well for us. So we're a successful business on the one side, but also we're on this quest. And then once Web3 and blockchain technology became much more of an evident thing, we saw that was one of the great ways to potentially solve this problem for us in data sharing and data trustworthiness on a peer-to-peer network, basically, where we could have data from different sources and be able to have people use it, especially in a case where you don't have to have consensus on a piece of data, kind of like IPFS, where you can just look at the data itself, and the properties of that data is actually evident on whether or not it is correct or where it belongs in the system.
Mm-hmm. You mentioned data trustworthiness, and we talk about a lot about people can make up data in a spreadsheet and people can download data from a database. How do you know the data is trustworthy? What is your rubric of determining that?
Well, the most important thing to me is just kind of two things. The transparency is very important. A lot of people think that privacy is very important for keeping data secure and good and clean, but to me, transparency is. So if you can always tell where data came from, what other items it was linked to, who else saw the same data, that is actually the web of data that you need to be able to get this triangulation on there. It's kind of like the real world. I often use the legal analogy where you have a jury and you have witnesses and that sort of a thing. Some of our terminology we use in XYO kind of mimic some of that, because if you want to know what happened in a car accident, for example, at an intersection, you can go and ask both drivers and you can ask all the people who are watching it. You're going to get 100 different stories. But how do you take those 100 different stories and come up with the most likely correct story of what actually happened is really what the goal is there. And that's kind of the same thing with this, where, for example, if I'm measuring the temperature at the Rose Bowl, am I measuring it indoors or outdoors? I could be measuring both, and they could both be correct, but they're different. So maybe the question is, well, what's the temperature at the 50-yard line, for example? And so how do we take all these different data points? How do we know where they came from? Who actually reported them? What's the sequence of data? Was it ever changed? And so making the data permanent also is a big part of XYO, where not being able to modify data after the fact. So that's where our proof of origin chains come in, where we link these things with hashes and with signatures. So once I've reported certain data, I can't go and change what I reported or remove something or add something in the chain there.
Right. So the blockchain acts as the kind of archival aspects of it. What about the sense making, right? If you have a lot of data points, and we know this from like big data, where there's a lot of people collecting a lot of data about consumer behavior and apps, and a lot of what data science team in these big company from like Facebook or Meta is to make sense of that data. What is the layer between the actual archival and the sense making of the data? Is that something that the network provides, or you see that as a layer as well in this Web3 world?
Well, we kind of have three primary components. We also have a bridge, which is our fourth component, but the primary components are what I call a witness. And what a witness does is it takes data from the real world or off-chain and basically observes that data and signs it and puts it into the sequence of its proof of origin chain. that basically is onloading or data onto our system. And then we have the archivist, of course, where we store all this data. And then the other thing which processes data or produces blocks is the diviner. So what the diviner does is it takes existing data from various sources and comes up with aggregate data from that. So, for example, if you ask a diviner what's the temperature of the rose bowl, it might go look at 10, 20, 100, 100,000 different data points it got from all these different observers that are out there, these witnesses, and come up with an answer that gives you a certain degree of certainty on that answer based off of all that. But the single observation in a vacuum from a certain witness is assumed to be correct from their perspective, right? It's kind of like asking somebody their opinion.
Yes.
You can't tell a person that their opinion is wrong, but if you look at a whole bunch of people's opinions, you can come up with, well, what's the average opinion for this group? So the observation itself is permanently in the blockchain, but then the way you take all that data and make an aggregate answer out of that for usefulness purposes. So it's really the transition between data and information.
Yeah, like the interpretation and the trustworthiness. As you have a larger pool of data points, you can be like, hey, this is actually whether it's the median temperature or like the weighted average temperature that makes you more confident. How do you think that compared to the approach of the kind of the current generation of Oracle, where they look at different price point reported by different price Oracle to determine a particular conversion rate? That is a relatively simple thing, and that can be done on-chain, off-chain. You're talking about 100,000 data points or more. That seems like a lot of processing to be done on the blockchain. What is your technology solution for that analytic to be actually able to process a large amount of data to do that reduction to generate that information that is useful to other people?
Well, largely our system is predicated on how much is a person willing to pay for a certain amount of certainty, right? So if you want to take 100,000 data points or a million data points and crunch through all that to get a certain level of certainty, you can pay more gas to do that. If you are willing to trust, less data points, that's fine as well, especially if you want to specify certain addresses of the sources of those because you trust those. So say, for example, I have a witness on there which I run. I might give more weight to my own witness because I know that it's got a higher probability of being correct. So I can actually weight the witnesses for my own personal needs because of my level of trust of the partner or myself of running that witness. If they're witnesses that are out in the open, you can analyze their histories and you can see what their reputation is. Or you can just take a very, very large number of witnesses and boil them down, get rid of the outliers and that sort of a thing. But the cost in there, one of the things that's really nice about the system also is that you can basically see the data which was the answer was based off of, because you can use whether it's a Bloom filter or it's just a list of hashes of these were all the inputs I used to come up with my answer. So given an algorithm for what's the average temperature at the Rose Bowl, given the same number of inputs, the answer should always be the same based on how that diviner actually runs. So the fact that I can get the answer and I can get a hash tree or I can get the source data transparently to me, I can go and rerun the analysis if I want to and get the exact same answer. That also means if a second person goes to ask the same question within a short period of time, we could use that same answer. We can say, well, if you want to save money, I'll give you the answer that came in 5 minutes ago. And so how fresh do you want the answer to be and how certain do you want the answer to be is really the two metrics which determines how much you have to spend on getting the answer. So if you want answers real time with 100% of the data, it's going to get really expensive, but there are ways to minimize that cost.
Yeah, I think it's interesting to look at we talk about AI explainability, but repeatability is important, right? It's sometimes very hard to repeat someone else's analytics because you don't have access to the raw data. But when the data is on chain and you can observe it, you can say, hey, I don't believe in your saying where's your raw data, and you can start with that and compute it again if you don't trust them.
Correct. Or in our case, a person could potentially be using data that is proprietary or is private, but we have the hashes for it. So in the future, if a person wants to say, well, this is the data I used, they can prove that that was the actual data they used because the hash matches the hash. So you can potentially keep data private, but still included in the input set with its hash without having to expose that. And so that way it makes your answer permanent. And in the future, it's just in time privacy.
I see. Does that affect composability? Like, it would be nice to be able to use someone else's output when they figure out the the Rose Bowl's temperature and then maybe another, Tropicana field temperature, and then you do something on it. Could we use someone else's information in the input for my analysis, or is it something that I have to go back to the source to kind of build it from scratch?
Well, the format of our blocks is the same for whether it's new data that's been imported from a witness or if it's data that was produced from other data. So the only difference would be the one from a witness would not have input hashes, so you have to know what it was composed from. And so depending on what types of schemas you understand as the diviner, you can use schemas that are either composed or schemas that are fresh data that comes into the system, depending on what what your settings are.
Yeah, I think the composability of DeFi is always be able to use the output from one system as an input in another system, not necessarily having the raw thing, and that type of composability really drives successes in be able to kind of cut the shortcut to get to more valuable data. Do you foresee a situation where these valuable data are actually sold on your network, as in like this data that has been synthesized from these thousands and 100,000 source is inherently valuable as a product, the same way people will buy data feed from Bloomberg? Or do you see that as a public good that is being kind of generated from these kind of like raw data points or stages of processing?
Well, it really depends on the person who's paying the gas to get the answer. So, for example, our system can allow you to ask a question, post that question publicly, and then when the answer comes in, it's posted publicly. So the next person that comes along, they can just look at your question and they can see the answer immediately for free. But what you can also do is you can set our system to, instead of posting the answer publicly, you just post the hash to the answer publicly, but you give me the payload guts for that, the JSON that makes that hash. So that way I have the answer. I can prove I had the answer at a certain point in time because the hash is public. And then if you want to come and ask me for it, I can charge you for the actual body that's in there and say, well, I have this answer from 3 minutes ago or whatever it is, and I'll charge you a certain amount for it. And especially in situations where the time after the calculation affects the price of it, or also how many people know it. If I've sold it 3 or 4 times already, it's worth less than if only you're the first person buying it. So that's that market dynamic of whether it's for the public good or whether it's for personal use is really up to the user, not up to the protocol itself. I would love to see more public use aspects of it, but at the same time, that's not really the purview of the protocol itself.
That's really interesting, right? Because a lot of data within blockchain has been data about crypto, about prices, about trading advantages, and you can see companies charging a lot of money for a little bit of intelligence on top of the public data. There's good business model there, where you have chain analysis on one end selling to governments, and you have Nansen selling to like day-to-day traders that intelligence. So we definitely know that there are value ascribed to a certain amount of private insight, but how do you know that they're computing correctly? And that hash thing is really interesting, where that it's publicly proved that it's derived from this public data, but it can have a private value. Do you foresee a marketplace emerging from these kind of data marketplace? There are projects like that's working on either streaming data marketplaces or at rest data marketplace. Do you see that as part of XY Network strategy going forward?
Well, we have a lot of that in place right now already. A lot of that marketplace currently is running through more Web2 technology. So a lot of our partners, what we do is with our Coin app, we give them access to some of this data, and they call it through a RESTful API on a Web2 sort of interface, just because from an efficiency standpoint and from a technological integration standpoint, it's a lot easier. But our goal is to try to move that more towards Web3 in the future. But I think actually it was Jack Dorsey who coined the Web5 thing recently, where basically it's take the best of Web2 and Web3, and I feel like XYO has been doing that for quite a while, where a lot of our current customers access us via Web2 interface, and then we're kind of the intermediary where we do the XYO the distribution to our data providers, and then we produce those answers. So we kind of wrap a Web3 solution in a Web2 envelope to give people, like current people, access to the system without having to force them to go into the Web3 world. So I think looking at Web2 for scalability solutions for Web3 is something which a lot more companies should be doing, as opposed to just trying to make Web3 that much better, because there's some of the problems have already been solved, and especially like in a system like ours, which is a consensus-less system. It's a lot of people think of blockchain as having to be a shared central ledger that has consensus for every single block, but that's not how XYO works. All of our our different blockchains are individuals chains themselves, and they're signed by one or more parties. So they don't need consensus of every single node in the system. If that was the case, it would come to a screeching halt. So I think our scalability is much more predicated on the Web2 technologies that are being used in there, even though we use Web3 style cryptography to be able to make it into a proper modern solution.
Yeah, I think it's very interesting to look at the additiveness of Web 1 and Web 2, right? So when people think about like, that the personal ownership of Web 1 and then the network of Web 2, and that gives you that Web 3 model, right? Which is that the we can add that economic model on something that's individually owned. So in your opinion, looking at this kind of Web 2 technology distribution, do you see a world where Web 2 company will actually be using the Web 3 data in their day-to-day work in delivering like mobile apps and Android apps? Are you seeing that trend where instead of thinking about mass migration to Web 3 as a consumer experience, it's really about taking the Web 3 consensus or information gathering and using it in a more Web 2 delivery way?
Yeah, I definitely think the Web3 aspect of it allows us to have like a payment structure for our data, and also a way to make it decentralized. And making a decentralized solution in Web2 is really difficult. So I think I would expect, at least for the foreseeable future, most of our internal systems will work in Web3 world, where a lot of our partners who want to buy data, for example, would access it through a Web3 a Web2 interface, very similar to like people who analyze often right now. They analyze Ethereum blockchain. They don't do that by running an Ethereum node. They just get a key from Infura to go and download all the data from that and analyze that. So they're really accessing Web3 via Web2 interface, which is an Infura connection.
And then they're sometimes delivering the insight in a Web 2 way, in a website or in a subscription SaaS service or a private kind of like access, consulting services, right? But how do you deal with the data availability? Do these blockchains doesn't have to have the cost of consensus, but it would be good to be able to have other people run a node and get access and get the replica of the data from the witness and the archivist. What's your kind of like the closest model for that data availability aspects we mentioned a little bit earlier? One can talk about a little about that. It's because it could be a lot of data.
Right. So, well, some of the data can be reduced a little bit because it could be just hashes, for example. But what our goal is to have really low cost, almost no cost, public archivists, so people can store tons of data in there. And then the data which people want to keep private, that's up to them to actually have their own private archivist for that. It's kind of similar to IPFS, where I can give you an IPFS hash, where if you have the picture or the file or whatever it is on your private server, it exists, it's still there, but I can't access it unless you give me that access to that server. So the way for a person who wants to make sure that the data which they have persists forever, basically the immortality of data, is to make sure that they either they run their own node or they pay for some sort of a backup service where there's other archivists which are replicating this. But our goal would be to have the vast majority of this data, especially data which has been deemed to not be Byzantine in any sort of way, or also is not repeat data. We would store a lot of that in our public archivist. And one of the nice things also about the hash system that we have is that if two different observers look at the same thing and come up with the same answer, that block will hash to the same number, right? And so we don't have to store that twice. You only have to store it once. The same way that if we both have the same image and we get an IPFS hash for it, we only have to store the image once. We don't have to have two copies of the image. So it's kind of it borrows some from S3, it borrows some from IPFS, and it's the general principle of all data already exists. All you have to do is find the hash for it, right?
As far as like collecting like the data input part, do you want developers who are building mobile applications or beacons to format the data a certain way that can be brought into the network? Like, what is the ingestion part? Like, if someone were to try to collect data about people bumping into each other in a conference and want to store that kind of incident data in the XYO network, what is the process of kind of connecting that real world kind of device into this network?
Well, so the way our SDK works is we have a handful of witnesses which we've produced in there, which will do things for you. Like say it's a Bluetooth witness, or system information witness, and that sort of a thing. But a person can also build their own witnesses. So if they can get the data that we can't get to, they can either use existing schemas for those witnesses, so they can have a different way of witnessing something that's formatted the same way as our existing schemas, so that data is much more interchangeable. Or if they want to, they can either extend those schemas with their own things, or they can make proprietary schemas from the ground up. So really how interactive it is really based on how clean their schema design is and whether or not they're actually making their schemas compatible with existing schemas that are out there. Or in many cases, I would suspect most people would just basically use our SDK and use our existing witnesses with the schemas that are already in there, and they'll just provide the data or run those as needed.
Yeah, it's what you're mentioning Web 5, right? The Jack Dorsey announcement. In that document, it's like the most common word was schema, right? Like I actually extracted the text from that particular PowerPoint and I put in through a word cloud, and schema came out first. And as a data geek with a history of doing data analysis and big data and stuff like that, it's like, yep, agreeing on the format of how you collect the data is like the first step to interoperability. So starting with an existing set of schemas seems to make sense. So what kind of schema is out of the box with your Witness SDK that would be useful for people trying to collect the data at the edge or in the field?
Well, we have some simple.
Just give us some example.
Well, the most root schema is the schema actually. So it's the schema which defines how a schema is defined, right? And so
Right.
all that really basically is it tells you where the section is in the JSON that actually defines the schema. But then inside that we have a payload schema, for example, which is just for any payload it has to have this structure, and that schema is basically just it has to have a schema field which tells you what the schema is, and then we have a bound witness schema, which is the way that you sign and you collect bound witnesses into a bundle. So those are some of the prime like almost like root level schemas that we have in there. We also have an ID schema, for example, where it generates a UUID for you, and then it uses that in the thing there. We have a time schema, for example, a location schema, those sorts of things. Location schema can come from a few different sources, right? It could come from GPS, it could come from location services on a phone, it could come from a person just basically dropping a point on a map for that reason. So those primary ones are pretty simple. And then we also have some more complex schemas, like for example, current price of crypto schema. So it's like these are the observations of, say, the Uniswap prices for certain pairs, and then there's the schema for those, and then we have an answer schema of, well, what's the current price, and we can go and look at all these different pairs and come up with a different price for there. So the schemas can get pretty complicated the more levels deep you go on there, and in many of the schemas cases, they actually as you said before, they use data as inputs, and so the further, like if you're 3 or 4 different levels deep in using inputs from previous outputs, then your schemas are get pretty specific and pretty complicated. So if your schema is something like the current functioning of your car, it's like the how well is all different parts of your car working. That's gonna be a very, very specific, narrow use case for it, but it probably will be composed of a whole bunch of smaller schemas that actually make up that answer. It's not going to be just this one giant schema.
Yeah, like the engine temperature would be a more like lower level schema, and that might feed in like your gas tank, how full it is a simpler schema. But telling me the health of my car, that is pretty specific to the car.
Correct. But a temperature schema could just be a temperature, and the gas tank could be a weight or it could be a pressure. And so taking those things and then building them into, it's almost like data Legos in many ways.
Yeah, I mean, if you think about what people do in Excel all day long, they are just kind of making schema up by columns and things, and they're cooking it up from sheet 1 to sheet 15, right? Like, and then kind of migrating. And I think people who worked in data have a general intuition about that refinement of insight from raw data on sheet 1 to the final report on sheet 78 that helps an investment bank decide to do something. But I think that is so private, right? It's within one user's laptop, and it's, we're just saying, hey, this refinement process is much more collaborative. We can write these data and define these columns and the relationship between them in a more public way. Is that roughly coincide with kind of like Excel in the blockchain, or is it something that it's more refined than that?
I would say it's probably more comparable to structured data, for example, that Google uses on websites, where they can go and search the website, get the structured data, so you can see what companies is this website about, or what persons is this website about, or what products is this website about. So structured data and JSON schemas, we actually use JSON schemas as our schema structure for the JSON payloads that are in there. Those are probably more similar. And if you look at the structured data, the way that Google has defined those, they're pretty consistent across the internet, because for you to be included properly in the search results, you have to kind of conform to what Google says. These are the important fields for you to have. These are the what should be in there and that sort of a thing. And if you make your telephone number a string that doesn't actually conform to a telephone number, they'll probably just ignore it, because they'll so people are compelled to actually make good, clean data there just because they want to be included. And so that we want to piggyback a little bit off of things like that, where there already is some consistency in schema structure and schema design out there, rather than trying to invent our whole new schema ourselves.
Yeah, I mean, schema.org, obviously is a collaboration from multiple search engines, Google being one of them. And if you don't make your website export those schemas, you won't show up in the little box that says flights or like products and listing. That all requires additional work. And the world of search engine, just looking at text is really actually passe. It really is a way of providing structured data by way of the open web in this specific way. And again, to Jack Dorsey's TBD organization, they cited very many schema.org schema in their examples of the data sharing. So I think starting from that web 1, web 2 schema.org seems to make a lot of sense. Do you see a certain type of schema emerges from like a collaboration process? Because if you to add a schema to schema.org, you got to be one of the contributor from a search engine with a job as like a head of data or something like that for it. What do you think is the process in Web3 that will be necessary for us to either decide that we don't need to agree on any schema, or some process to kind of narrow down the schema so we can have more interoperability? What's your sense of the social process there?
Well, I think the way we're looking at it is from a domain standpoint, where we have our schemas that we publish on network.xyo. Well, we reverse the domain name for the thing, so it'll be network.xyo the name of the schema, and so that's basically the xyo.network one. And the root of that is made authoritative by having a file or a DNS entry, so we can prove we own the domain. So for people who want to make their own schemas, they can use their own websites to do that. So there could be like com.google.schema names if Google wanted to make ones for XYO and so on and so forth. And I think there'll be a natural coalescence around certain domains where, if Google has specified these under their thing for search, then people will start using that. And then if people have ones that are good that they want to ask us to add to our network.xyo ones, we can do that as well. So we can have a public repository of schemas that people can use. But I think it'll just happen over time, where people will they'll glom on to certain schema providers out there. So most solutions will probably be a combination of highly available public schemas and completely private schemas for the solution provider that's actually making the software.
Yeah, it's amazing how much, I've been in the technology industry quite a while, how much Java got right using the reverse domain name to give people their own little namespace, and then how the JavaScript ecosystem, which came after that, is like, hey, global namespace. And it's like, hey, that's pretty hard to do. But it's good to be able to have that kind of, use a domain name system as an address book to find both common things and also uncommon forks away from that. I think it's pretty intelligent. I have something that I want to ask about kind of the role of the token. Like, obviously the network itself costs money to do. And is that the main purpose of the token, is as a kind of a fee to the network for the diviner to do the processing, or is there some other roles for it?
Well, it's really meant for all the components where, if a bridge is bridging or an archivist is storing or a witness is witnessing, those all would get paid as well. But I do see that the largest chunk of gas usage or compensation for work will probably be in the diviners, partially because they have to go pay to get the data potentially to actually get it from the archivists. And also they have to spend a bunch of time processing that and being able to come up with these different answers. And if they have to do it fast, like for example, if people want more real-time things, they're going to have quite a bit of CPU power and connection to do that. So I would imagine in the future, probably way more than 50% of the XBIO spend in our network goes towards diviners,
Mm-hmm.
and then bridges probably have the least amount of spend on it because all that is really just forwarding packets. And so it's kind of like, how much
Yeah.
does a fiber optics cable at Verizon get paid? It's almost nothing.
Yeah, I think the economics of thinking about token as some version of gas. I think when the Ethereum network was first forming, gas was a product. You're buying block space, right? Like that's essentially what you're paying for. And in this case, you're buying for that computation, not for global consensus, but it's for your own kind of someone devoting real CPU and real bandwidth to your particular quest. I think that's a really great way of making sure that token are tied to products and services that are consumed versus just like kind of like a future idea of something. So it's really really great to see that there is there's like a utility on a product on this. Do you see the XYO token being more of a governance token as well, or is it mostly just for this utility purpose?
Oh, we've thought about that as potentially being a governance token, but yeah, right now there's not that much to govern. It's kind of
Mm.
more of a consensus system, kind of like Ethereum or Bitcoin, where if the majority of people on the network do a certain thing, that kind of by default becomes the rule. So the consensus is almost like a byproduct of the evolution of the network at that point. We happen to be the driver of the network right now, so we have the most um, interest in actually getting things done and to do that. But for the foreseeable future, I see it being just the utility gas aspect of it. I think if we were to have some sort of governance thing in the future, or we wanted to have some sort of a voting system, we probably would introduce a derivative token of some sort.
Yeah, to treat the XYO token kind of as just paying for services, gas token of similarity.
Correct.
Okay. When so like to kind of bring it full circle around the idea of trust and availability, there are a lot of projects is working on right now on like the Oracle problem, and obviously you have this particular kind of extensible way of doing it. Is it, and you have some use cases you have mentioned in your white paper and your green paper. Do you see XYO as a horizontal application layer to kind of apply to almost any type of data sourcing, data processing, or do you have certain vertical use case that you think would be like the divine direction that you want the network to be primarily known for? Is it more multi horizontal or multi vertical?
It's more horizontal, I'd say, because from my
Mm-hmm.
perspective, I look at it as all data is created equal, and certain data might have higher need to have higher certainty, right? So the verticals I can see coming out of it would be something where those verticals have a need for the solution, because I think a lot of people who do blockchain and crypto development, especially with the Web3 thing, kind of similar to the .com days, is once they see the hammer, they think everything's a nail. So I'm the first person to say
Mm-hmm.
that there's probably plenty of things out there which don't need XYO signing and overhead and blocks to be able to make them better. And those people should not be using
Yep.
XYO. So there's probably going to be a natural evolution of a handful of verticals that actually thrive because the value that XYO brings to them is very substantial. And there's going to be a few other ones where people might play around with them. Where, like, take video games for example, like you're not going to be able to get a high performance video game out of it necessarily, but you may be able to have the inventory system
Yeah.
for it running on XYO. So a portion of it, the inventory control might be a really good vertical, but the actual rendering or the real time running of the game may not be on the blockchain.
So is kind of like the derivative data, the ability for to make sense of something that's already happened. That's a better use case than the real time kind of like cursor movement. that probably is not fast enough to be something that you want to go through that network beyond just a game server.
Yeah, well, I don't see, even though XYO is substantially, like, orders of magnitude more performant than Ethereum is, for example, because of the lack of need of
Mm-hmm.
consensus. It's still, my last time I did a calculation on this, Ethereum is somewhere between 5 and 7 orders of magnitude more cost prohibitive and performance prohibitive than Amazon Web Services. We're probably
Mm-hmm.
still,
Yep.
2 to 3 orders of magnitude less performant than AWS if I have a dedicated server that's just running on AWS, completely trusted by me. So yeah, if
Right.
that
Right.
solution works for somebody, it's really hard to convince them. Well, pay an order of magnitude more money, or lose an order of magnitude of performance just so you can have decentralization even that this decentralization does not really actually provide a huge benefit for you.
Yeah, I think it's important for people to know that, you know, any type of decentralization does incur a cost. It's whether that cost, that order of magnitude cost, makes sense for your use case, whether you want that trust or trustlessness, depends on how you look at it. But it's definitely not free. Having a machine running in my own computer on the cloud is probably the most efficient, right?
And maybe someday we can
So,
have that.
is there yeah, go ahead.
Let's say maybe someday Web3 or decentralized solutions will have that efficiency, but it's not going to happen in the next few years. I can guarantee that.
Yeah, I think right now a lot of the blockchains are still very bound to processing and latency and data storage. I am quite excited. I've talked to some projects that's using GPUs to do some really interesting data processing stuff, and that's really efficient. And it does happen in the cloud, and you can pay Google Cloud Platform a lot of money. But part of me is like, what can we use all the GPUs that's going to be being sunset from the Ethereum mining exercise and do some interesting data processing. That seems such a waste to see those things pile up on the side of the street. But I know they're selling it to gamers and stuff. But I think GPU analytics and AI is going to be really interesting to leverage that hardware.
And also, trusted execution environments, I think, will also be very interesting. The GPUs can't help with that necessarily, but I think there are certain cases where having chips that can basically operate on data without sharing that data, I think is going to be a very important part of the future of data processing on the blockchain.
Yeah, I think SGX from Intel was a technology. I spoke with one of the key engineers who was coming out of the Israel labs. That technology is being deprecated right now in Intel, so we probably have to wait for the next generation of the chips that can do the trusted environment. I think it's important for us to be able to move private computation that is now trusted because they're private. Run by big multi-billion trillion-dollar companies to one thing we can trust people like yourself and myself running that thing in the node and still have that same level of trust. And I think that's definitely a goal of that decentralization without losing that trustworthiness. That's really cool. Is there anything else in our conversation I missed that you would like to highlight to our collective audiences?
Not specific. That's really the overview of XYO and why it exists. I think a lot of people realize that we kind of, when you touch on this, we've kind of become a little bit more of a vertical solution where we've moved away from the location specific stuff. We obviously location and time is a very important aspect of data in the real world. So if you're making a reality article, where something happened and when it happened actually is very important. So time and right. Location is still a very important part of the XYO network, but it's more of a meta concern than a primary concern at this point for our data. And I think we realize that nobody wants just location, because if I just say to you, New Jersey, like, well, what's happening in New Jersey? Yeah. Like, why New Jersey? It's just giving you a location doesn't have much meaning, but tying something to it, whether it's an event or it's a thing, there's a house in New Jersey for sale for a certain amount of money or whatever it is, that's the important part. The fact is New Jersey at a certain point in time is important, but it's not the primary data in there. So I think with XYO 2.0, we've really transitioned from being what a lot of people think of as a location, like decentralized location, to a decentralized reality oracle, which uses location and time.
It's the same way I have a location tag in my photo. The photo is the main ingredient. The location is nice, but it's not the primary thing, right?
Exactly. Imagine if you shared with your friends all your location tags, and that's it. It wouldn't be interesting.
Yeah, that wouldn't be too interesting.
Right.
I'll just be jumping around dots, right? So, well, thank you so much for kind of giving us information about this. As a technologist building in this space, one of the things I always like to see is, people working on a particular domain where there's location or something like that and having an insight. It's like, hey, this is like generalizable to a whole layer of a stack that can be shared infrastructure for this Web3 stack. That's why we talk about the land of the Web3, like any nice piece of land, like the Americas or North America. It's a lot of land. There can be many things going on, but there is this shared infrastructure, shared standard that allows things to be compatible with electricity, blah blah blah. And I think we are seeing the emergence of different teams and projects realizing that their experiments becomes this infrastructure, and we're just trying to figure out who's doing what and try to stay synchronized on certain things and bring a solution to the market, not only for developers building on top of it, but obviously ultimately for end user getting the benefit of it. So thank you for continuing the journey and pushing on and providing this insight that can only come from having shipped multiple products to figure out, hey, there's a thing that can be a common good.
Okay. Well, thank you very much. I really appreciate being on the show today. And I always love talking about this stuff. I'm really passionate about it. So.
Yeah, you're very knowledgeable about the actual nitty-gritty of it. It's very easy to get caught up in terminology in Web3 and making jargon, but you drill down 1 or 2 level, it really is just the evolution of technology. Web3, Web5 is just technology continue its arrow to the time forward, and it's always great to talk to people who are committed to and see a certain direction and go and lead and guide people towards that. So thank you so much.
Thank you.
So as always, thank you to the community for your time and attention. We do this a podcast premiere every Wednesday at 9 a.m. Eastern. And until next time, take care.